So in our final example, we've got a gasoline tank, a very large one, because that's really what's underneath of these gas stations, isn't it? And it's cylindrical. It's laid down on its side. It's 5 feet in diameter and 12 feet in length. It's 4 feet below the ground, and yet we want to pump the gas not just out of the ground, but 3 feet above the ground, like maybe the height of a gas pump. So we're actually going to be taking this gas tank that's underground, pumping gas out of it to a height of about 7 feet above the tank, 4 feet to get up to the ground level, 3 feet to get up to the pump. So we're going to be looking at little incremental layers of this. If we were just to skim off a tiny little bit of gasoline from the top of wherever the tank's filled to, what shape would it be? And I believe that's what you might see in pink over here. I tried to draw it on the picture right over there. And hopefully it was successful in allowing you to see exactly what it would be. But the shape we're probably looking for here is, well, I don't know. What do you think? A rectangle? So if it's a rectangle, that should make it kind of easy to find this. Um, the only problem is, how do we get that rectangle here on our graph? So basically, if I looked at it from the end, way down here, on the graph that I drew down below here, um, it has a circle, and the circle's equation is just x squared plus y squared equals the radius squared. How do I figure out exactly how wide this is? Because my rectangle, well, it's going to have a length of 12, and then it's going to have, well, whatever that x value is that goes out to the side of the circle. The width of my rectangle is going to be 2x. And if you really want to talk about the volume, you've got to add a certain amount of thickness, just a little change, an incremental nudge dy. So we would need to come down here and actually solve this equation, the one that's in brown on the bottom right-hand side. If we were to solve that to find out what x is actually equal to, that would give us an idea. So we've got this square root of 25/4 minus y squared, the square root of all of that. Boy, does that make the volume layer up top look a little bit different now. So if the volume is the length, whoa, that's a very strange thing to have music just suddenly come on like that. Not sure why it did that. Anyhow, the length of this is 12 feet long. The width of it is 2 times x. And the thickness would be just a small change in the y value. That gives us the weight of this. Remember, the weight is basically going to be the force. We have to pick up that weight and move it up a certain distance, the distance that it's going to travel, any amount of gas that we have, 19 over y, 19 over 2 minus y. So basically, that's from the center. What happens if the gas happens to be at a level that is a negative y value? What if it's 2 feet below our x-axis on our drawing over here on the right? Well, we'd let y equal -2, and it's actually going to be 19 halves minus a -2. So it's actually 19 halves plus 2. It's actually 2 feet more than that. So whether the gasoline level is above the x-axis or below, a positive or a negative number, it still should work out just hunky-dory. That leaves us with a lovely little equation here. The bottom of the tank would be minus 5 halves below the level, and the top would be positive 5 halves. I'm going to take the weight of this tank, or at least the increment that we're looking at any given time, times the distance that it has to travel. I know I should put the dy on the end. And that is our integral. Now, this is going to be a very special integral. We're actually going to take a minute to show you how to solve this.